Now I think we can switch to English and let's get started. Good morning to another lecture here in our course, and today we are going to spend the hours that we have for recapping Entity Framework Core, and I will show you some additional tricks which we didn't do in the previous years. You already have pretty good base knowledge regarding Entity Framework. However, it has been some months since we last used Entity Framework, so therefore we are going to recap things. Now what I have created for you, let me pull that out so you see it better here, is I have created a sample which we are going to walk through. This sample is available in our course repository under the folder samples and then something with to do Entity Framework. And inside of this sample, I have created a README file for you with some kind of checklist, which will hopefully help you to remember the most important steps to get started. The reason why we are going to recap those basics is that this will be super relevant for your final exam, for your Matura. Here you see how you can set up your computer for getting ready to work with Entity Framework. Remember, you have to install the Entity Framework tooling. That's .NET Tool install. We have one student in the room who is new to our class, so this is the first step that you need to do in order to run the Entity Framework tooling. For the rest, I encourage you to run the .NET Tool update to make sure that you have the latest version of the Entity Framework tooling on your computer. So that's a one-time setup. I cannot tell you already whether this will be done on the computers on which you do your Matura, your final exam. So I will tell you, maybe it is a step that you need to do before we get started with the final exam, but I will tell you later. So we will see how that works out. Here in school, our de facto standard is working with SQL Server in the 4th and 5th grade. So therefore, you need two NuGet packages when you work with Entity Framework in ASP.NET Core applications. You need the SQL Server tooling and the design tooling. So Microsoft Entity Framework Core Design and Microsoft Entity Framework SQL Server. That will be relevant for creating the application, which we will do in a second. Now on your computers, you will need SQL Server running. You can either, if you run on Linux for instance, run SQL Server in a Docker container, and I have added here for you the Docker command that you can run in order to spin up a SQL Server. Feel free to do that. If you run Windows, you can install SQL Server Express LocalDB, and that is relevant for you. I added the link to this README file, so you have to follow the instructions on this website. You do not need to do it immediately. You can if you want, but in the break, I encourage you to install that. If you have any problems, please let me know, okay? Everybody else just told me that you have already installed that. For interactively working with the database, I encourage you to try the Azure Data Studio. We did that already in the past year. Azure Data Studio is cross-platform. You can run it on Linux. I know many of you run Linux instead of Windows. That's perfectly fine. However, note, very important, for your final exam in the exam room, you will have to develop on Windows first. And second, you will probably not have the Azure Data Studio, but you will have the SQL Server Management Studio, which works nearly exactly the same. If you would like to prepare perfectly for the final exam and the exam environment, I suggest that maybe until next week or when we see each other in 2 weeks, you additionally install the SQL Server Management Studio. It's called SSMS, SQL Server Management Studio. It is available, I think, for free. I think it's part of the SQL Server Express LocalDB. But don't worry, if you do not want to install it or if you can't install it because you're running Linux, absolutely no problem. SQL Server Management Studio is extremely similar to Azure Data Studio, and the SQL statement that you type in are exactly the same. So it's really not a big difference. But I want to avoid that you are confused when it comes to the final exam. Are we good? So these are the system requirements that you have to make sure that are present on your computers. Any questions regarding those system requirements? Very nice. So let's get started and let's create an ASP.NET Core minimal API with .NET 7 and Entity Framework 7 from scratch, just to make sure that we can remember everything. Okay? It will be now mainly a recap of minimal API plus Entity Framework to make sure that we can remember everything. And now, please remember it and don't forget it for approximately half a year. Then it's no longer my problem. You know what I mean. So for the next half year, you shouldn't forget what we are going to do now. I'm just kidding. Of course, I want you to remember that for a longer time, but yeah, whatever. I'm going to create a new ASP.NET Core minimal API project. I'm going to call it to-do-ef .NET new web API. And please open it up in your favorite development environment. Regarding the final exam, of course you will have Visual Studio Code installed in your environment for the final exam. However, you will also have Visual Studio, and as far as I know, you also have Writer. Will anybody here use Writer for the final exam, for the Matura? Okay. Last time I had a Matura here in the school, I had some Writer fans, and they preferred using Writer, but I had to explicitly talk to the administrators to make sure that the licenses are there and so on. Good. So now we have our to-do entity framework CS proj. That looks good. I'm going to open the program CS and we can clean up the code a little bit. Remember this Swagger open API stuff, we don't need it for this exercise, so you can delete these lines here. We do not need the Swagger and Swagger UI for this exercise. We do not need HTTPS for this exercise. We do not need the sample data for this exercise. We do not need the map get here for this exercise. The only thing that we need is this app.run. That is essentially the minimum web API that you can create. It contains no endpoints, but it spins up a web server and yeah, it waits for HTTP requests, but it does nothing. Please make sure that you clean up the program CS so that your code looks somewhat like that. So the first thing that we need to do in order to get started with Entity Framework is we need to build a modal. And in our case, we are going to build a rather simple modal with a slight extension that we didn't do last year. If I can remember correctly, we didn't do M-to-M relationship, many-to-many relationships. But this time we are going to do it because it's very likely that in the final exam you will have to deal with many-to-many relationships. So let's create a new file. I will call it database modal, but you can call it whatever you want. Let's define the namespace to do EF, like entity framework. And here we are going to create our database modal. First, we need a user entity, public class user. Let me get rid of GitHub Copilot because it will spoil too much. Okay, can anybody remember how you call a property that should become the primary key? Yep. ID, correctly. What is the data type? Int ID. Well, you can use int, or you could even use a string data type. Does anybody have an idea what the database will do if you select a string data type for the ID? You will get a so-called GUID. Do you know what a GUID is? A global unique identifier? Yeah, you're nodding your head. Perfect. So you can choose between string and int. I will do int because it's easier to type in when you do some manual SQL statements. I like that. So remember, ID is a convention. You will get a primary key with auto values if you use that one. You can remember that. I like that. Next, we are going to add the name of the user. So prop string name, something like this. Give it a default value, something like this. And if I want to specify some additional properties like the maximum length, I can use data annotations, something like this, to specify what's the maximum length of the name. And that will influence the structure of the database. It will make sure that the database column is 50 characters long. So do not forget these data annotations. Here you see the data annotations. They are important. There would be a different way of specifying these data annotations, the so-called Fluent API. You can Google that if you want, Entity Framework Fluent API. I will do the data annotations to not confuse you with too many options, but I just wanted to tell you for real life, larger applications, typically professional entity framework coders use the Fluent API to specify these things. So I will just write it down here, alternative Fluent API. This is a research job for yourself if you are interested, if you want to know the details and want to become real professional entity framework developers, please research yourself. Next one, we need for our to-dos tags. Public class tag. Well, the first steps are rather simple. I will simply copy the code from up there. It has also an ID. Every entity here has an ID, a primary key, and let's call this one description, okay? Not name, but description. So now we have tags, we have users, so we can go to to-dos. Public class to-do, not EF, to-do, this one. Of course, I am going to have an ID, public int ID with a get set. Then we are going to have a title, prop, string, title. I will not specify a data annotation here. Question: what will be the length of the column in SQL Server when you create a string property without the max length? Yep. No. There is a special data type in SQL Server. It is called nvarchar max. It's just the maximum length that's possible. The maximum length has a lot of different influence factors, the maximum length of a record and so on, thousands of characters. Okay? So the data type will be nvarchar max. It's not bad, not a bad choice. If you want to have the maximum string length, then you can definitely do that. Let's add another property, which is, oops, sorry, prop, good. Boolean is completed. Good. And now we can start modeling the relationships. Now, how should the relationships look like? We have on the left-hand side our user. Oops, here. We have on the right-hand side our tags. And in the middle, we have our to-do. Now we have a relationship from to-do to user. On the left-hand side, we have a 1. So each to-do is assigned to exactly one user. Every user can have 0 or n, 0 to n to-dos. On the other hand, it's a little bit more complicated. Every to-do can have n tags, and every tag can be used in m to-dos. This is a many-to-many relationship. So physically in the database, we will have an additional table here in the middle. It will be called something like to-do tags, something like this. Then we have a relationship here and a relationship here. The relationship of this table will be, no problem, will be 1 to n and 1 to n. And the green entity will be inserted by Entity Framework automatically. You do not need to care for it. You simply model the n-to-m relationship and the green one will appear magically. You do not need to care about it when querying the database. It just appears. Okay? So let's try to build up exactly that data model. This is a kind of data model that you have to be able to master when it comes to the final exam. It will probably even be a little bit more complicated. Maybe you have 5 or 6 relations. But in general, this is the level that you have to master. Good. So let's start with the user. Every to-do item has one and exactly one user. What do I have to change in the to-do class in order to model that relationship? Who can remember it? Yes? Yes, exactly. We add a user ID, which is the foreign key, and we add the user. User, user. However, as we know, the navigation properties typically are nullable because we can decide whether we want to include them or not. So we specify a question mark. Because we use the integer type here, the relationship is mandatory. Every to-do must have a user. If the user would be optional, we can use a question mark here. So with this optional property here, with this nullability in line 31, we define whether the relationship is mandatory or optional. Remember that. The relationship here will always be optional because we do not need to read the user. Okay, so very nice. Now the next thing that we have is we have multiple tags in a to-do. What do I have to add to the to-do class in order to tell C# that we can have multiple tags? Yes? A list or an I collection or something like this. Let's stick to the list. Let's keep it simple, okay? List of tag, that would be tags. And at the end we can say create an empty collection, something like this. Quick note. In C#, in the next version of C# in .NET 8, you can write it like that. Okay? That is a so-called collection initializer. So in .NET 8, you can write it like that. But I promised you that we will stick to .NET 7 until .NET 8 is finally released in a few days or weeks. So let's stick to simply new. Nice. Now let's go to the other side of the relationship. User. What do I have to add to user? Who can help me? Yes. Exactly. A list of to-dos. List of to-dos with new. Always the same template. Not complicated. But now comes the interesting part. What do I have to add to tag? This time it's a N-to-M relationship. While the answer is simple. Just a list. So for an N-to-M relationship, we simply have a list on both sides. Prop list of to-dos. That's the whole magic. Again, if you want to become a real professional entity framework developer, you have to look up the details of N-to-M relationship. There is a lot to say. You can configure a lot regarding N-to-M relationship. There is a long documentation article about N-to-M relationships in Entity Framework. Here, in this course, we cover the basics. I want you to be really familiar with the very basics. And if you will need Entity Framework in professional programming once you leave the school, you will need to read the rest of the documentation, okay? But it's my job to prepare you for the final exam and to give you the basics, the understanding of the basics. So I think this looks pretty okay. We have our user, we have our tag, we have our to-dos, we have the relationships. Any questions? Good. Very nice. What is the next thing that we have to add? The database context. But in order to add the database context, we need to add the NuGet packages that I told you before. So the easiest thing to add these NuGet packages is to go to my GitHub repository and simply copy out these two console statements. See? So what you can do, you can copy this one, go into the terminal, paste it here, press enter, wait for a few moments, and everything will be done for you. Good. Yes, for the final exam, you will get the entire entity framework documentation. And yes, for the final exam, you can use, I think, one A4 page with notes or something like this. So if you want, you can write these two statements on your notes, for instance, and then you do not need to think about it. Good. Nice. If we check that, CS_proj, and you will see here and here we have the two NuGet packages. Everything is good. Now that we have these NuGet packages, we can add the database context. Let's do exactly that. That is a class, public class. I will call it application data context. You can call it DB context, application DB context. You can call it whatever you want. And it's derived from DB context. This one here. And the DB context, this one, lives in Entity Framework Core. This is part of Entity Framework Core. Now the DB context always looks nearly the same. I also copied you that in the checklist here. So here you see how you create a DB context. This DB context contains one constructor. If you want, you can copy it. You do not need to type it in. I will simply copy it, put it here. It's always the same. It's fine like that. And the second part that you need in the DB context is a DB set for every table in your database. So I will copy this one and I will use it 3 times for tags and for to-dos. And with that, our DB context is done. There are 2 important methods which you could override. The first one is on modal creating, and the second one is on configuring. These 2 methods are in practice, once you go beyond simple Hello World applications, very, very important. And most entity framework developers override them and use the already mentioned Fluent API to configure details about the data model and things like that. In this course, we will not go into the details. However, I wanted to point out that these 2 methods are really, really important. And you should definitely read the documentation if you want to go beyond the basics of this course. On configuring, on modal creating. So let's remember that. Any questions so far? Very nice. If you take a look at the checklist, the next thing that I added to the checklist is the possibility to add this data context to dependency injection. And again, I wanted to make your life easier, so I added for you the code that you need to copy into your ASP.NET Core project. So simply copy this line here, go into your program CS, oh, I already have it here, and here after the builder, you can simply put it here. The only thing that you need to add is a little bit of usings. This is a using here, and this is a using here, and with that, you should be fine. With this statement, with this single statement, you make the database context available in all your ASP.NET Core handlers. I hope this cheat sheet will come in handy for the upcoming exams and for the homework. It should make you simply faster. It should not be necessary to learn that by heart or to Google it or look it up in the documentation. This statement references the connection string here in the app_config JSON, the app settings JSON. Here we should have our database connection string. Now, if we go here, we need the connection string. And what I did in the cheat sheet, I added 2 connection strings for you. One connection string is for Docker, that's the upper one, and one connection string is for localDB, that's down here. So please choose whatever you want. I will use the Docker one because I think I'm running it here on Docker. I will check that in a second. simply copy it here. Obviously, you will have to maybe change the password depending on your settings. Please try to enter the correct connection string. I will quickly make sure that it's still running. Yes, I have my SQL server running. It's running here, it's listening on port 1433, and it's called Frosty Sukowski, whatever that is, but it looks good. So please add the connection string depending on your environment. Important note for those of you who use Linux. If you use Linux, you have to turn off invariant globalization. I will not go into details what that is. Just trust me, it's a good idea. Otherwise, you will have problems. So go into your csproj file. Where is it? Here it is. And add this setting to the top property group. It's only for Linux. I think on Windows it will just work. It will just magically work. Good. And with that, we have recapped all the steps necessary to set up the database use in our project, and you learned something new, end-to-end relationship. I think we are ready to create the migrations and create the database. Can you remember what migrations are? It's generated code necessary to bootstrap the database. So I will do the following. I will quickly spin up my Azure Data Studio. Here is my Azure Data Studio, and go to my localhost computer. And I hope that my Docker container still runs. Yes, here it is. And you see, I already tried that one. Let's quickly finish that, and then we'll make a break. And I simply will drop my existing database. You do not need to do that because you do not have this database yet. So I will say drop database to do EF so that I have exactly the same environment as you have. Now my database should be gone. Exactly. So I have an empty environment. That looks good. Let's just create the migrations and then we'll make the break, okay? .NET EF migrations, add, and then give the migration a name. Initial schema or something like this, whatever you want. Run it. The system will now build the code, and once the code was built, it will hopefully generate the migrations. And see? Done. The migrations should be available here, as we learned it last year. So please try to do that. If you have any problems, we will fix them after the break. But we reached a nice intermediate step on which we can build on after the break. So let's do a short break. Okay, so let's get started. Let's continue after the break. Do we have any open questions that we have to discuss before we move on? No, we don't? Very good. So let's continue. Let's build the very first query in our program.cs. You didn't miss anything, we just started, so it's fine. I will write one line and then we will discuss this line, okay? app.mapget, and in the mapget we will say users, and here we will say our application db context. Here it is. Let's call it dc, like data context, and then let's say dc.users. Now this line is seemingly simple, but there is a lot going on here. Let's try to figure it out. Can anybody try to describe what this line means? Let's start from the very left. What does the get mean? You should definitely know that. Yeah. Exactly. We provide a handler, an endpoint for an HTTP GET request. What does that /users mean? This question is so trivial, I don't want to even ask it. It's the path on which we listen. So an HTTP GET request with the path /users. Now this application DB context is available because before we added the DB context to dependency injection. So we get injected the database context. You should remember that from last year. But now comes the tricky part. What the heck is dc.users? Well, we can take a look at dc.users. F12, it's a DB set. Okay, it's a DB set. We can simply return a DB set to ASP.NET Core and it knows what to do. I mean, what's going to happen? Somebody has to issue the query, right? The important note, the important thing that you have to remember is that ASP.NET Core, listen closely, we didn't discuss that last year in detail. ASP.NET Core is capable of receiving any IEnumerable and IQueryable, so any collection that is in memory or inside a queryable database, and it will automatically iterate over the collection, and with that triggering the database query for you. It will intelligently pull the data out of the database, convert it into JSON, and send it over the wire to the end user. Got it? So this is a very important takeaway. Yes, you are allowed to return an IQueryable, a DB set is an IQueryable, or an IEnumerable directly from an ASP.NET Core handler. Last year, I told you over and over and over again that if you want to access the database, you always have to use async. And you always have to use the async methods and call it using the await method. Can you remember? This is probably the code that we would have written last year. And this year I tell you a secret. If you simply want to return a database query, you do not need this async await blah blah. You can simply leave it out and return the query itself. And ASP.NET Core is smart enough to recognize that this is a DB set. This is an IQueryable. It will trigger the database query. It will get the data out of the database query. It will convert the data into JSON, and it will respond in a very efficient way to the end user with the data from the database query. Got it? This doesn't need to be a select star from without a where clause. You can easily add a where clause here. You could say something like u.name.starts with foo, something like this. That's also fine. That's a query. You do not need to call toArray or toList async. You can return the query directly. It doesn't need to be a complicated query. It can be a query without filter, but it can also contain a filter. Got it? However, there is a big however here. In real life, it is absolutely not a good idea to directly return the objects from the database through your web API. Why? Because in general, you want to keep your data structure of the database private. That's an internal implementation detail. If you want to restructure your database, if you rename a column, if you rip a table apart into two tables, if you do any kind of restructuring, you do not want your APIs to change. So in non-trivial scenarios, it's not a good idea to directly return database structures from a web API. Well, in practice, sometimes you are in a hurry. Sometimes you build a pretty simple API and you just want to get things done. You do not want to invent 7 layers with DTOs and so on. You simply want to get things done. You have limited time, limited budget, and you have to deliver. If you are in such a situation, this is your friend. Just do it. But be aware that it's not beautiful. It's not a beautiful software architecture. But software architecture is all about compromises. Sometimes speed, development efficiency is more important than beautiful design. And then you can do that. But if you want to have beautiful design, future-proof design, You should always work with these DTOs that we discussed last year, and we will also introduce DTOs in this example. But still, today I wanted to show you what ASP.NET Core is definitely capable of. Questions? Good. First endpoint, check, done. Let's test it, okay? So what I invite you to do is I invite you to open up your Azure Data Studio, just like I did, just to practice that we can interactively work with the database. So let me refresh my database list here. There is no database yet. What did I miss? Yeah. We already added migrations. Yes. Yes, update the database. Thank you. Thank you very much. This is the step that I missed. Before we can do anything with the database, we do need to .NET database update. Let's run this. Let's run the .NET database. Oh, sorry, EF, of course. EF database update. That will take our migrations, apply them to the database, and create the necessary tables for us. Yep, looks good. No errors on my side. Now I refresh it again. And now I was successful. I have a database, and just as promised, I have my to-dos, I have my users, I have my tags, and can you remember? This is the relationship table for the many-to-many relationship. It was created automatically, although I didn't manually specify it. See it? Now this is exactly what we want. Please try it. I added, where do I have it? Here, I added, of course, here, these two statements to your cheat sheet. So you see here the .NET EF migrations add and the .NET EF database update. Good. If you are successful, please add a single user just to see whether everything works properly. So what we can do is we can run an insert statement, insert into users, name, values. What do we do? Let's say here food bar. Oh, I have no idea. Oh, sorry. Yeah, now it's good. What? Connect. I lost my connection. Run it again. Oh, sorry. Of course. Name, what did I do? I am in the wrong database. Good, now it works. So now we have one user in the database. I'm sorry, up here you can select the database, and I was in the master database and not in the to-do EF database. That was my bad. Good. And now I can run the application, .NET run. And let's do a test request. So what I do is I create the requests.hdp file. You can also use Postman if you like. Get, what is it's 5040. So that is HTTP localhost 5040 users. Let's run it. And hopefully we will get our foobar user. Everything works properly. And here you see how ugly this is, because we get a list of to-dos, which is an empty array. And this is exactly the problem that you have when you directly expose your database objects onto the API. But nevertheless, it works. So please try it. Make sure this works on all your machines. Let's do a short pause and wait until it works on everybody's computer. Nice. I think we solved all problems. Well, nearly. One problem we couldn't solve that requires a reinstall. However, you saw when I run this request here that I will get this ugly to-dos array. I can easily get rid of that one by doing a query. What we can do here is we can say select And what we can do here in this select, we can return an anonymous object. Let me show you how this works. I can simply say new curly braces u.id u.name, something like this. And then if I restart my app and rerun the query, now it's done. And you see, I only get those columns. So this, I don't know if we did that last year. Maybe we did. If we did, that's just a reminder. That's a so-called anonymous class that we return here. So we simply build an object with the new operator. Behind the scenes, C# will generate a class for us with some random name, will assign these properties, and return only those properties back to the client. The important thing that I want you to remember this year, last year I wasn't that critical. It's important to do that because by specifying the columns that you want to return, you avoid reading unnecessary data from the database. Imagine that you have a table which contains 200 fields and you only want to return 3 because that is what the Angular application is waiting for. Then you definitely should do a select here and return only those 3 columns that you're really interested in. You shouldn't read the rest of the 197 columns from the database because that places unnecessary load on the database and makes your app slower. So, rule: the best and most efficient data is data that you do not store. Don't store things that you do not need, first. Second, the next best thing is data that you currently don't need, do not read it. Avoid reading unnecessary data from the database. The third is if you need to read it, but you don't need to transfer it to the client because you only need it for some calculation purposes, then do not transfer it to the client. Okay? So do not store data that you don't need. That's especially true because of data privacy reasons. GDPR, DSGVO, you know what I mean, personal data, only store what's really necessary. Only read data that you need to read, only transfer data that you really need to transfer. Otherwise, you're wasting precious energy, resources, CPU time, network bandwidth, and so on. Are we good? Does it make sense? I hope it does. So this year, I will be more critical with your applications, and I will probably reduce some points from your exam if you do unnecessary reads or unnecessary writes. Okay? Last year, I was more relaxed on that. Good. Next one. Next one is let's try to read a single user. app.mapget users, and hopefully you can remember from last year that we can specify dynamic parts in the query with the curly braces. So this time we are going to have an async method with the application DB context, this one, DC, and we get the ID. I hope you can remember how this worked because I asked you to do homework until today where you need to recap the web API stuff. If you are rather new to this web API stuff, you can find recording of my lessons from last year on the internet. You can rewatch the video. You are new in this class. Maybe some of these things are new for you. Ask if you have any problems. Check out the videos if you need to recap something. Okay? Good. Now, let's try to read the user that we are interested in. Let's do that. Var user equals to await dc.users.first or default async and read the user with the user ID like that. Then we can check if the user is null. I prefer is null here. Return results dot not found. And if everything is okay, we can say return results dot okay user. We have this, results, of course. We have the same problem here with the user that we have up here. So what we could do in order to return the same data structure, we can also do the user dot, this one, user, so that we return exactly the same data structure as above. No problem with that. This looks okay, right? This is the code that we probably would have written last year. Something very important is missing. Here, with users, please add as no tracking. To be honest, I'm not 100% sure whether we discussed as no tracking last year. Did we? Perfect. Can anybody describe what as no tracking is? Yep. What does tracking mean? You're right. Entity framework does not track the entity. What does tracking mean?
We change the entity.
Yeah.
Yeah.
Perfect. You said if we change the object and we say save changes, it will not update the object. That's true. But what does tracking also mean? What does tracking imply? Tracking implies that, listen closely, that's important. Tracking implies that every object that has ever been created by this data context will be remembered by the data context. And if you reread this object from the database, it will check, oh, did I ever hand out this object with this primary key? And if yes, you will always get the same object instance back. So it will remember, it has a brain, it has memory, it will remember all the objects that it ever read from the database. That means it takes a lot of time. Somebody has to maintain this list of objects. It has to stay in memory and things like that. And if we don't need that, if we want to not place this burden on entity framework and simply say, hey, I'm not going to update, as you said, I'm not going to use it in context with an insert statement, I'm not going to write anything, it's just data that I want to have out of the database, you do not need to remember it, then you add this as no tracking. So this is the thing that you should remember. When you just read data and you have no plan to update or use this object with an insert or delete this data, always add as no tracking. It makes your app a little bit faster. Nothing bad is going to happen if you miss that, but it's not efficient. So we try to be as efficient as possible. Good? Nice, let's give it a try. Let's rerun the app. Let's go to requests. Let's copy the get statement here. Let's try to get the user 1. And you see, it works nicely. Please try it. Please make sure that this code works. Very nice. I like that it works everywhere. Let me show you something with regards to the sample that I created for you. We are now programming exactly that sample, and please let me show you the code if you haven't looked at the code. What I did in this example for you to have the possibility to recap what we did, for every single step that we just did, I added a lot of comments. You see it here? Where I described, where I've written down all the things that I'm just telling you in this lecture. So once you prepare for the exam and the final exam, you can simply go through the code, and the code contains additional tips and tricks. So I will not write the comments now as we do it live, because you hear me talking. But if you need to recap, take a look at the code. It contains a lot of comments, if you see. So this is hopefully useful for you. Good. Nice. Let's do something which is a little bit more interesting. Let's do a query on the to-dos, right? Let me think. No, we are not going to do a query on the to-dos. First, we are going to do something else. We are going to write a simple helper method which fills our database with random test data. Because otherwise, It isn't a lot of fun. If we query a database that is nearly empty, that's not funny. So let's try to write a method, an HTTP endpoint, which we can use to refill the database. That will be the thing that we do first. And I ask you to do it as follows: app.mapPost with fill and async application db context dc. This is what we have here. So here we want to do two things. We want to remove all data from the database, and then we want to fill all tables with random data. Please remind me, did I tell you about the NuGet package bogus last year? No? So let me show it to you. Bogus is betrügerisch, gefälscht, erfunden, fingiert, geschwindelt. This is the translation of bogus in German, and it's a nice library that I like to use. It's called Bogus, and if we take a look at the website, you can simply Google it. You see that Bogus for .NET is a port of a library which is called Faker.js. And what you can essentially do, let me show you an example, is you can here fake data. You can say fake data and use the class order, and then you can define faking rules. You can say the order ID should be simply incremented, but the items should be a random fruit from a collection. The quantity should be a random number. The next one should be a random number. And you have faker rules for a lot of different examples. Let me show you that. You have faker rules for addresses. You can fake cities, zip codes, countries, street names, and so on. You have fakers for departments, prices, categories, product names, colors, and so on. You have fakers for, you see that all here. You have fakers for dates. You have fakers for finance. You have fakers for hackers. You have fakers for images, and a lot of other fakers. And if you need it in a business context, you can even, where do we have it? Buy the premium version, where you have GPS related fakers and a lot of other fakers, as you can see here, from biology and pharmaceutical and so on and so on. So the authors of this bogus library, they are trying to make money by distinguishing between a free open source version, which is perfectly fine for our purposes, and a premium version for professional companies who want to fake even more advanced data. So you do not need to come up with your own data. You can easily generate random data using Bogus. And this is exactly what I would like to show you in this example. Now, if you want to install Bogus, you can simply run .NET add package Bogus. Let me show you how this works. Let's do that, and then we'll do a break, and after the break we'll add Bogus. .NET add package Bogus. Please do that. That will install the Bogus library to our .NET application. And you see, CSproj, we now have Bogus installed in our application. So we can start faking data. Let me zoom in again so you see it better. This is the statement that you need. Is it necessary for the final exam to remember that one? Probably not. Maybe I will give you an existing method which generates random data, and it's your job to take this data and fill it into the database. Something like this could happen. But I'm not asking you to come up with a lot of random data. That will not happen in the exam or in the final exam, in the Matura. Okay, were you able to install this package? Do you understand why this is useful? Let me close with one important thing before we go into the break. Many developers make a crucial mistake when developing software. They write software and they test with very limited demo data. They test their applications with 1 record, 2 records, 5 records. And when they put their software into production, suddenly they don't have 1 or 2 or 5 records, but 10,000, 20,000 or 500,000 records. And guess what? The software will not work. The user interface will look crappy because your entire design was built with the assumption that you only have 5 records. Never do that. As a developer, you should test with lots and lots and lots of demo data. So if you are now working on your final thesis, on your Diplomarbeit, take the time and fill your application with lots of demo data with a platform like Bogus, for instance. And then try your app. Maybe it's too slow. Maybe the user interface has never been designed for tens of thousands of records. That is exactly the kind of testing that you need to do. And for those scenarios, Bogus is super, super useful. Are we good? Nice. So let's make a break, and after the break, we will fill the database. Welcome back after the break. Let's get started. Let's get started and let's fill our database. I would like to cover multiple topics with this little fill method. The first topic that I would like to talk about is database transactions. Can anybody describe what a database transaction is? Can you remember that from your database lectures? Want to try it? Yeah?
You basically group multiple SQL statements together.
Yeah.
Then you can roll back.
Yeah.
If something bad happens, so
Yeah.
you can save the changes to it.
Exactly. You just said you group multiple SQL statements into a transaction, and at the end you can say commit if everything was okay, or roll back if an error happened. So essentially, if you want to do multiple changes to a database, and either all the changes should be stored, or if an error happens, nothing should be changed in the database, that is what you use a transaction for. And let's take a look how transactions work with Entity Framework Core. It's not complicated. What you essentially do is you first start the transaction by saying using var transaction equals to awaitDC database.begin transaction async. This starts the transaction. This is like begin transaction in SQL, in SQL. Then we start a try-catch block. We start a try-catch block, and in the catch block here, if something happened, if an exception happened, we are going to roll back the entire list of commands that we did within the transaction. So we say await dc.database.rollback transaction async, and then we simply rethrow the exception. So if something bad happens, roll back the transaction and continue with the handling of the exception. Now the work itself is done within the try block. Here we do our job, and if we reach the end of the try block successfully, we say await dc database.commit transaction async. So let's take a look at this pattern. We start the transaction, and then we do error handling. In case of an error, we roll back. When we reach the end of the try statement, no error has appeared, and therefore we can commit the statements. Okay? If something bad happens, roll back. If everything is okay, commit. Question?
Is there a change if you just put the new transaction to the last row of the post, like under the catch?
Yes, it would definitely be not a good idea to do it like that, because this statement will also... No. Yes, it's okay. If you program it like that, I have to correct myself. It is okay because we rethrow the exception here. If you would remove this row here, then it would be wrong. But if you do it like that, it would be okay. But typically, you write the await commit transaction statement as the last statement within the try block. That's the typical thing that you do. But it is possible. Yes, you're right. Does it make sense? And we will experiment with that in a second, okay? Now let's talk about the process itself. First, let's remove all the data from the database. Please do not follow along. I will delete the code that I'm going to write now in a second because it's very, very inefficient. For instance, let's try to remove all to-dos. Do not follow along. Var to-dos equals to dc.todos.toArray async await for each var t in to-dos dc.todos.remove t dc.savechanges async. What is wrong with this code? Yes?
We don't have to save the changes until we
Absolutely. So let's remove that save changes from the loop and do a single save changes. What is wrong with this code? Can you remember the rules that I told you? Do not store data that you don't need. Do not read data that you don't need. Do not transfer data that you do not need. Do we really need to read all the to-dos in order to delete them? I mean, if we would do it in SQL, we would probably not say select star from users to then do a delete from users where ID equals something. And then we will do that over and over and over again. That's stupid, right? The only thing that we need to do is we need to do a delete from users, and that's it. Without any where clause, without anything. That will delete all our users, correct? So again, what is wrong with this code? It reads unnecessary data. Why should we read the to-dos in order to delete them? Correct? And for exactly that problem, Entity Framework 7 has a nice solution. Let me show you how this works. You simply say await dc.todos.execute delete async. That's it. So you essentially you add a query at the very beginning, and then you say and delete those records. You could even add a where clause here. You could say where t.description or title, something like this, contains blah. We could do something like this. This would be possible. Then it would be a delete from to-dos where title like blah blah blah. Get the idea? So this method is the new thing. This method makes things very much simpler. So in our case, we can simply say todos.execute delete async. Isn't that useful? I think it's very, very useful. And of course, we can now do the same with the tags, and we can do exactly the same with the users. And with that, we simply delete our entire database. So please remember that. Execute delete async is very useful when it comes to deleting all the data in a table or doing a delete statement with a where clause. Good, so now we can remove all the data from the database. With that, let's fill the rest of the database. First, let's generate some users. And with that, I want to introduce you to Bogus. Looks like that. Var user faker equals to new faker of user. And then we can add rules. Rule for the rule for the name. And then we can simply say faker user person dot full name. Something like this. This line tells Bogus to invent random names, full names, with first name and last name, and fill our users with that. And if we want to have users, we can say var users equals to user faker, generate, how many do you want? I would say 10. And with that, we get 10 random names. Isn't that useful? We do not need to invent our own names and Fu and Bar and Tim Turbo and John Doe and Jane Smith and whatever. This thing will generate the names for us. I will now write 2 lines, which we will discuss later on. dc.users.addRange, async of course, users. Oh wait. dc save changes. Wait. We will discuss whether we really need these 2 lines in a second. But for now, let's just assume that we want to have exactly those 2 lines. We'll discuss them in a second. Next one. Let's use a tag faker. Tag faker, new faker of tag. And then we have a rule. In this case, we have the rule for the description field. And there is a nice little faker which says lorem word. Do you know what lorem ipsum is? Yep. And this is super useful that Bogus has the lorem ipsum generator built in. So you can simply generate Latin sounding words, random words, and we can use them in our database. So it will not make sense, our tags, but it's okay. Now we have some tags. How many tags do you want? I think 10 is fine, right? Var tags equals tag faker generate 10. And obviously we are going to write the same 2 lines again, but this time we are going to add tags. We are going to add tags and save the changes. Again, we are going to discuss whether we need those 2 lines. We are going to discuss that in a second. Now, we need to fake the to-dos. I think by now you understood how this faker stuff works. And therefore, I want to make your life a little easier. So what I'm going to do is I'm going to show you where this is in my sample solution. So let's take this one. I will send this link via Discord to you. You got the link via Discord. And please copy. I think you can copy everything until line 209. Okay, you can copy everything until 209. Something like this. We do not need the comments. The comments are just for later when you do your self-studying. I think with that it's good. It's just exactly the same as we had before. Some rules. I use a lorem sentence. I use a random bool. I pick a random user. I pick a random tag. In this case, I'm not just picking one tag, but I'm picking multiple tags. Something between 1 and 3 tags per to-do. Because we have a many-to-many relationship. Can you remember? And then we are going to do an add range and save changes async, and that's good. And now I would like to have the discussion about exactly these 2 lines. My question is, do we need them? Question mark. Yes.
We definitely don't need save changes async because we did at the end.
Granted, we don't need save changes async because this save changes async will save everything to the database. So we can already get rid of these 2 lines. I agree. But what about the add range async? Do we need it? The answer is no. But why? The reason why we do not need these two lines, we can simply delete them, is because the users up here are referenced by the to-dos. See here? We are picking up users, we are picking up tags. And Entity Framework automatically inserts not just the records that you directly insert here, but it goes through the entire tree of objects. So if an object that you insert contains a reference to another object, then Entity Framework will recognize that this other referenced object is also new and will insert it automatically. If it's already present because you read it from the database, Entity Framework will automatically recognize that and will not reinsert it. So this is pretty smart. Yes, question?
Do we get minus points for missing this?
Very good question. I am not sure. Probably not. If you would add multiple safe changes, maybe. A tiny little bit. But the other one, well, yeah, it's not perfect, but it's okay. I'm not sure if I even would spot it. If it's more complicated, maybe I wouldn't even spot it. Yeah. But you get the idea, right? Sometimes it's useful to have that. Perfect. What do you think? Let's try to fill the database, right? So let's run the app. .NET run. And let's trigger the endpoint. This time we need a post method. Post. And we call the fill endpoint. Let's run it. No, come on. It's running, it's running, it's running. We got a status code 200. I would like to check that. So I go into Azure Data Studio and I will say select star from users. Let's run it. Oh yes, Kathleen Armstrong, Sadie Wastenet, Valerie Murray, and so on. So you see, we got a bunch of users, 10 users, just as we specified. Did we get some tags? Yes. Not very useful tags, but they are tags. Did we get to-dos? Yes, we got a lot of to-dos with lorem ipsum inside. Some of them are completed, some of them are not completed. And did we get to-dos, tag to-dos? Yes, we also got tag to-dos. So everything was filled correctly. Question?
If we only add the to-dos, will the user text to insert that weren't picked?
Yes, they would not be inserted. Very good question. Let me repeat the question so that everybody understands and hears it. If we create a user, and if it happens that this pick random never chooses one specific user, then this user record would not be inserted in the database. If you absolutely want all of the 10 users to be inserted in the database, then you would need the add range, the additional one. Very good question. Exactly. So how's it? Did your endpoint fill the database? Yes? So what you learned and what you need to remember from this demo is how do we write transactions? That will definitely be part of your next exam, and it will nearly definitely be part of your final exam. So you need to remember that. You learned how to efficiently delete all records or a filtered set of records from a table. You learned about bogus, and we talked a little bit about when and why add range is necessary. Good. Question. Can you create nested transactions was the question? Yes, absolutely. It's possible. But remember, if you create a nested transaction and you do a single rollback, the entire hierarchy of transaction is rolled back immediately. So you cannot say begin, rollback, commit. That is not possible. And I can show you that. That's not a question of Entity Framework. It's a question of SQL Server. Let me show you that. If I say begin transaction, something like this. Let's write it in uppercase. Then we say another begin transaction. Begin transaction. This one. Then we say rollback transaction. And then we try a commit transaction. Something like this. If I run this thing, I get an error in line 7, this is this line, that commit transaction has no corresponding begin transaction. Why? Because we have a single rollback. That doesn't work. But if I change this rollback to a commit, something like this, then everything is fine. So the system has an internal commit nesting count, and this nesting count is decreased whenever you say commit. But if you do a rollback, immediately the entire hierarchy of transactions is rolled back, and yeah, all the changes are undone. Did that answer your question? Good. There is something which is called a transaction count. I can't remember the variable. T-SQL transaction count. Yeah, tran count. What you can do is you can query how deep you are currently nested into the transaction. So you can count the number of begin transactions at tran count is the thing. And if you, for instance, need to conditionally do a commit or rollback, you can always ask, do I have a tran count greater than 0? And only then you can do a commit. If the tran count is 0, then you cannot do a commit. Somebody else did a rollback. Got it? Good. But again, this was a very good question, but it is a limitation which comes from the database, not from entity framework. Mm-hmm. Yep.
I have a question now.
Yes.
Why don't we use the transaction? Transaction method or like that? We use the DC database with transaction
What you want to have is, or what you want to use is a wait transaction dot commit async. Feel free to do so.
Does it make any difference?
That's a very good question, and to be honest, I would have to Google it. Let's look it up in the documentation. I think the way I showed it to you is the one that Microsoft mentions in their docs, but I will check that immediately. I'm not 100% sure. EFCore transactions. Let's see. Using transactions. Very good question. Let's see. Oh no, they do a transaction.commit. Okay, I'm fine. Then I stand corrected. This definitely works. You saw that it works. But if Microsoft does it that way, let's fix it, okay? Let's fix it and let's say transaction.commit async. And this would then be transaction.rollback. There is no rollback async. Yeah, there is a rollback. Ah, here it is. I don't know why IntelliSense didn't show it to me before, but okay, now it's good. Yeah, we are fine. I will have to look it up what the exact differences are between these two options. I'm not aware of a difference, but maybe something is different. But you're right. Let's do it in the way that Microsoft suggests it's in the documentation. So, yeah, let's do it that way.
Can you do it problematic if we have multiple transactions? I mean, how does the framework know which transaction to commit?
It is not possible to commit anything except the latest transaction that you started. The database simply doesn't support committing a transaction that is not the latest transaction that you created. It's simply not possible. So you only have a commit transaction. If we take a look at the T-SQL commit transaction statement, let's take a look at it. Then the T-SQL commit transaction allows to take us a transaction name, but I'm pretty sure that it only allows us to commit the latest transaction. Here you see it. This is the answer to your question, and I will let's write in this case. Because transaction name is ignored by the database engine. So if you specify a transaction name, SQL Server simply ignores the transaction name, and therefore it simply commits the latest transaction. Okay?
Yeah.
Good. Now I think we have answered the questions. Very good questions, by the way. Good. Any further questions? Yes. Go on.
We're using keywords.
Yes.
What does it exactly do?
What does it exactly do? The question is, what does the using keyword do? Now, if we take a look at what this begin transaction returns, it returns an IDB context transaction. Now, if we look up IDB context transaction in the documentation, here it is, then we will see that this IDB context transaction implements something which is called IDisposable. IDisposable is an interface in .NET that signals that an object can be explicitly freed. Typically in .NET we have a garbage collector, right? You know that. We discussed that, and I think you even discussed that in the first or second year in this school. At least I do it with the second graders. So IDisposable is a little bit different, because with IDisposable we do not have to wait until the garbage collector cleans up the transaction. Imagine that you simply forgot to do a commit or a rollback. Your method simply doesn't say commit or rollback. What should the database do? The answer is it will roll back the transaction as soon as the garbage collector cleans up the object. Now, when will the garbage collector clean up the object? Answer, you have no idea. It can happen immediately. It can happen in a few seconds. It can happen in a few hours if you are unlucky. So it's not a good idea to rely on the garbage collector for something as critical as a database transaction. And the using keyword that you see here, this one, says, hey C#, when this variable goes out of scope, meaning we are ending this method, clean it up. Don't wait for the garbage collector. Immediately clean it up. And this is what the using keyword does. If you would miss this using keyword, then the system will wait until the garbage collector cleans it up. Well, not in our case, because we manually call commit or rollback, so it would be fine. But if you would forget the commit or rollback, then you would have a slight problem in your code. So therefore, it is a good idea, it is best practice to always write the using keyword in front of an object that implements IDisposable. Good? Answers the question? Very good. IDisposable is important. If you haven't worked with IDisposable before in previous years, we should maybe discuss IDisposable in more details at a later time in the year. It's a very interesting topic. Further questions? Good. Very good. So, fill, check. You got that one. And with that, we can go back to our queries. We already queried the users, and now I told you that I would like to query the to-dos. And this time, we are making it a little bit more interesting. Okay? So let's do an app.mapget to-dos, and let's let's ask for the application, DB context, DC, something like this, and do it like that, and so on and so on. So now in this application, I would like to allow the end user to specify 4 query string parameters. I would like to enable the following. Get HTTP to-dos. I would like to enable something like Q equals to shopping. So that should be a query filter for the text, for the title of the to-do. Then I want to have the possibility to have a done filter, done equals false. Then I want to have the possibility to do paging. So skip the first 5 records and only take the next 5 records. So here I can do paging. Take 5, takes the next 5, take the next 5, and so on and so on. Understood? So this is what I want to implement. Let me quickly get rid of that one here. Yep. Let's add the necessary filters. The first one should be a string optional title filter. The next one should be a bool optional done filter. The next one should be an int optional skip. And the next one should be an int optional take. We can make it very clear to the reader of our code that all these 4 objects come through the query string, not the path, by specifying here an attribute that says from query. That simply makes it easier for a reader of our code to understand where these filters come from. Technically, they would not be necessary. But I added a little tricky requirement here. Take a look at the requests here. This one I called only Q. And this one I called done. But here I called it title filter and done filter. In order to rename the query string parameters, we can write name equals Q and name equals done. See? With this syntax, we can rename the query string parameters. So we can have a well-defined, easy to read parameter name, and we do not need to have this long parameter name as part of the query string. Understandable? Does it make sense? Perfect. Now let's do the querying, right? Can you remember how you can conditionally build a query? This is what we are going to repeat today. I'm going to create an IQueryable of to-do, and let's start with all the to-dos. And then we can use a series of if statements. If not string.is null or empty title filter, if we have a title filter, we can add a where clause. Query equals query dot where t dot title dot contains, and let's add the title filter. Got it? I think we did that last year, right? You have a base, return everything, but you do not immediately execute the query. You have an if statement, and conditionally, if there is a filter, we are going to add a condition. Otherwise, the query remains the same and returns everything. Then we can do the same with the done filter. If done filter is not null, then we need to query equals query dot where t dot done, no t dot, how did I call it, is completed, equals done filter. And I think you can imagine what the last 2 ifs are. Now we handled the title filter, we handled the done filter, now we need to handle skip and take. So if skip is not null, very simple, query equals query skip skip. What value? And if take query equals query take value. Does it make sense? Let me maybe reformat that a little bit so it's easier for you to see everything. I will put everything in a single line so that we have everything on a single page. Sorry, something wrong here. So let's do it like that. Let's remove the empty lines here and simply return query. So let's take a look at this structure again. We start with the select star from to-dos. All the to-dos, completely unfiltered. And then we conditionally add 1, 2 where clauses. We conditionally add a skipping of certain rows, skip over the first 5 results or something like this. And then we add a take clause where we limit the number of rows that we want to get back from the database. Everything always conditional with the if statement in front. Got it? Make sense? Can you remember this pattern from last year? I'm pretty sure we covered it. I'm not sure how far we went, but now you should definitely understand it. What's bad with this code? 2 things are bad. One thing is definitely bad. Yep. Sorry, I didn't understand it. Yeah, and that is fine. That's perfectly fine because Entity Framework will combine multiple where clauses into a single where clause in the resulting select statement. So that is absolutely no problem. That works perfectly fine. You could add it with and, but this is much simpler so that you can build it in a structured way, componentized. So this is perfectly fine. Yes?
There's stuff that data that we don't really need.
Exactly. We return the entire to-do object that we don't really need. So what I would do here, in this case, I would definitely like to do some selection. Maybe we can make it like that. We can say return, or let's do it like that. Query equals to, no, that doesn't work like that, sorry. Select, and then let's do to-do, and here we say new, and here we say, for instance, let's return just the title, and let's return the is completed. Let's return the username, and let's return the tags. And from the tags, let's just return the description. Something like this. We need to give it a name, tags, and now we are good. Now take a look at this select statement. It's very interesting. We are now doing way more complicated stuff than last year. This select statement tells us, hey, only return the title, the is completed flag. Now take a look at line 43. That is an important one. Join the to-do table with the user table and retrieve the name of the user from the joined table. Understood? Isn't that beautiful? In database lectures, you have learned that you need to write this blah, blah, blah in a join. You do not need to do that in Entity Framework. You simply say, here, user, join the user, and give me the name from the user. Even with, and this is important, please note here, even with many-to-many relationships, you can say for every to-do, give me a list of all the tags, and from every tag give me only the description. Think about how complicated it would be to do exactly that in SQL. You would need to have a subquery. You would need to have a nested subquery. We don't need that. Entity Framework does that completely automatically. Before we go into the break, let me quickly show you that this really works. You can try it, run it, first, I am going to try it without any filtering. Run it. Let's see if we get something back. Yep, I get something back. So let's add a filter. I will now add only a text filter, and I will say valid. Let's see if something gets back. Yeah, you see? Here is valid, here is valid. It works. Let's add a done filter. So valid, and the done filter should be false. Yeah, and you can now try skip and take, and it will also work. And take a look how nice this is. We only get back the data that we wanted to get back, so your point of criticism was perfectly right. We only return what we really need by using this select clause. And by the way, you can take a look at how much work Entity Framework freed you from doing. See this complicated select statement? See this complicated select statement down here with all the joining and the sub-selecting and whatever? You do not need to do that. Entity Framework generates all of that for you. And you asked whether it makes sense to have multiple where clauses? Take a look at this where clause. It was automatically joined with an end command here, so it's perfectly fine. To make a long story short, Entity Framework is a powerful beast if used correctly. And this is a nice method. We can even make it better, but I will show you that after the break. So let's get started again. Before we went into the break, we have created this map get to do's thing here, where we have these function parameters, where we build the query step by step with optional filters, and then we return a select clause here. The question that I would like to discuss with you is, how can I move this logic here, this whole building of filtering, into a separate function? Because in many cases you would like to do, how should I call it? Well, traditional procedural or structured programming, where you do want to extract certain larger logic pieces into separate methods, right? So maybe we need this filter in a second application or in a different place in our application. We do not want to embed it directly here within this handler method. So my question is, how? How could we do that? Imagine I want to have a function. I have no idea what it will return. Let's call it, how should we call it? Get filtered to do. And I have no idea what parameters come in. And I want to have essentially this logic inside of, well, now let's say this logic. This logic inside of the method. How? Suggestions. Who has a suggestion? Let's first discuss the input parameters. What will this method get as input parameters? What would you suggest? A query. What is the data type of the query? Good. Let's take that one. Good. What else? I agree. So let's take these things here. All the query parameters, obviously without the from query stuff, because we do not need this. Good. I like that one. So what could be the result of this method? This is way more complicated, right? Yeah. No. Let's think about it. If we say this is the query, let's say we create void. Okay, the method would compile. But what would be the result of this method? Void. Nothing. It wouldn't do anything. Yes, you have an idea? Yes, exactly. What we need to do is we need to return the same data type that the query that we received. So what we can essentially do is we can say return query. That is exactly what we want to do. We start with a base query and we add a bunch of where clauses and we return a query which now has potentially some additional where clauses, a skip clause and a take clause. You got what I mean? That's pretty nice, isn't it? So let's try to apply this knowledge to here. What we now can do is we can say var query and we can say get filter to-dos and pass in the to-dos here and a bunch of additional filter. The title filter, the done filter, the skip clause and the take clause. And with that we can remove all of this stuff. Nice, right? Do you like that? I like it, but we can do better. We can definitely do better. What I don't like is that all these link queries are always member functions of a query, you see? Dot where, dot skip, dot take, dot select. But our function get filtered to-dos does not say to-dos dot get filtered. It doesn't look beautiful. Can we somehow attach our method to a query so we can call it in a similar way than this dot where dot skip dot whatever? And yes, we can do that. Does anybody happen to know a concept in C# which is used to attach a method to a different type? Do you know it? Extension methods. Let me show you how this is done. We can create, look how this is done, a separate static class. You can call it whatever you want. The class name doesn't really matter. You can call it Hansi or Greti, or in this case, I will just call it database extension. Something like this. And then, please look at me and then try to recap. I will take this method here, cut it out, and put it into the static class. Then I will make this method static. And then comes the magic sauce. Fairy dust. Harry Potter. This. This is the magic word here. By adding this word here, we say we would like to append this method to any type that implements IQueryable of to-do. And suddenly we can rewrite our code here so that we take this method here and say dot get filtered to-dos and write it like that. So what we essentially did is we extended language integrated query. We wrote our own query operator. There is no longer just a where or a skip or a take or a group by. Now we have something new. Get filtered to-dos. To be more specific, this get filtered to-dos is even not the best name because to-dos, we don't need it because that's already part of the data type. It already says to-do, see? So now we can say get filtered, pass in the filter parameters, and we are good. And this is pretty powerful, isn't it? This can be reused in many applications. Oops. This can be reused in many applications. It works perfectly fine, and it is a beautiful structure. I know that some teachers in the school, they teach this idea of unit of work and so on, where you have a data context and you need separate classes and so on. You can do that like that, no question. But LINQ, Language Integrated Query from Microsoft, was built with this architecture in mind. That you have a base type, in this case it is a queryable of to-do type, and then you append your own operations on top of it. Was this hard to understand? Could you follow along approximately? Yeah? Good? Okay. I like that. Questions? To make it very, very obvious what these extension methods are all about, I want to show you something. Please do not follow along. I will go to .NET Fiddle and just show you a little bit what these extension methods are all about. So you really understand what's going on here. Let me increase the font a little bit. We are in .NET 7. Let's say a using system. You do not need to follow along. Again, imagine that you have a class person. This class has no methods, nothing like that. If we create this class, an instance of this class, var p equals new person, something like this. Okay? Now what we can do is we can write a static class, person extensions, and here we can add a public static void, do something with person. It doesn't do anything because it's just for demo purposes. And then I can say p dot do something with person. And that is now possible. This p dot something with person comes from this method. It doesn't work yet because the magic sauce is still missing. What I told you. You have to say this person p. Now we have an extension. So the implementation of the method do something with person is not done in person, but in person extensions. Why that complicated? I mean, I could implement this method inside of the person class. The answer is simple. I can extend any class with that. I can, for instance, say, hey, forget about this person thing. I don't need the person. What I will now create is a date time extension. I can take here, do something with date time, and I can simply change that one to date time. See? And then suddenly, if I new up a datetime value, var dt equals new datetime, I can say dt dot do something with datetime. So just like a mockingbird, no, it's not a mocking. What is a cuckoo in English? Mockingjay, just like a mocking. I think it's the mockingjay who takes his eggs and puts them in foreign baskets. I'm not sure. Kuckuck legt Eier in fremde Nester. Ihr kennt das vielleicht. Ich habe keine Ahnung. Ich glaube, so ungefähr ist es. This is what we essentially do. We inject a method into a type that we do not own. And in our application, we do exactly that using an interface. And because IQueryable is implemented by every table in every database, we inject methods in any kind of queryable, in any entity. And that is what we do with these extension methods. Got it? Nice. No questions? Everything clear? Good. So this is stuff for the final grade. This is not something that we do earlier. Okay, question?
Can we override an existing method of the database?
No. No, you can't. You cannot. What you were probably thinking of is at runtime changing the behavior of an existing method. JavaScript can do that. It's called monkey patching. But in C#, that's not possible. Nope. Okay, good. Are you ready for another advanced step? I have one final thing for you, because everything else is just a repetition. The final step. What we did here is we had a nice little select here. You see that one? My question is, what if I want exactly that logic here in a separate method? So imagine that throughout your program, over and over and over again, you want to return exactly the same structural object. You have not a single to-do query endpoint, but you have 10 different ways of querying to-dos, but you always want to return exactly the same structure of your objects. So you want to move that in a method, right? Let's do that. Let's do exactly that. Now, what does this method do here? It takes a to-do item and returns, well, what? Let's try it again. Let's try exactly the same. Question mark. Build to-do summary. We have no idea what it gets as a query parameter. We have no idea what it returns. I want to have exactly that code, that code in this method here. Return. So, help me. What is the parameter that we want to have? Yes, to do. I agree. To do T. Nice. Got that one. What do we return? No. Take a look at what we return. Do we have a to-do ID? Nope. Do we have a user ID? Nope. Which type do we return? Ah, you're right. I could return an object, but that's ugly. Yeah, it would be possible to return an object because in C# everything is an object. Yes, you can do it like that. But then we lose typing. So, yes, you are right, but please don't do it. Yeah? Absolutely, that's the point. This syntax here is creating an anonymous class. A class that doesn't have a name. If we want to work with this, we need to give it a name. And we do exactly what users just suggested. We create a record which reflects the structure. So we can do a record, let's call it to-do summary. And this record should contain a string, title, a bool is completed, string username, and string array tags, something like this. Did you think of a record like that? Yeah? So now we can here return the to-do summary. The record, if you put it in program.cs, unfortunately must be at the very end here of your application. Oh, I just deleted it. That was not a good idea. I'm sorry. So it must be at the very end. It's just a convention. I'm sorry about that. You have to write it down here. And now we need to restructure that one. But this is not too complicated because now we can say to-do summary. Something like this. And we can remove that one, change that one to a bracket, and remove that one. And we are nearly good. To array. And now we are good. So what we did is we introduced our own type. We can no longer work with an anonymous type. Understood? Oh, I see some frowning faces. Again, this code here creates a data type. This data type is called foobar with a lot of special characters. C# will create the class for you. You don't see it, but it's there. Believe me, trust me, it's there. But we can't touch it, we can't take it, we can't refer to it because it's not visible for us. So what we essentially do is we are simply creating this record on ourselves. And then here we return this one. Woohoo! Looks very good, right? So what we can do now here, we can simply say build to do summary T. And this doesn't compile. What a bummer, right? Why? I mean, it should work. The error message is really strange. An expression tree may not contain a reference to a local function. What the heck could that mean? Have you ever thought about how C# is capable of building SQL statements from C#? I mean, take a look at this code. Can we agree on that the where clause here is a C# function? I can prove that this is a C# function. This is a C# function as you can see it here. Can we agree on that contains is a C# function on the string type? I can prove that this is the case by pressing F12 and I see this is a method. Now try to follow my argument. C# takes this code and compiles it to intermediate language. You know that. Then it takes this intermediate language and compiles it to machine language, right? And then somewhere at runtime, when we execute this code, it should be capable of magically translating this stuff into SQL? How? Do you think it takes a look at the machine language, looks at this method, at the compiled method, assembler language, tries to reverse engineer at runtime what this contains does, and translate it into a like clause with a %? Of course not. So what else could it do? The magic that happens in this link stuff becomes apparent when we take a look at the type of the parameter that we return, for instance, here in a where clause. Take a look at that one. This where clause gets a lambda function. You know what a lambda function is. We have worked with them over and over and over again. It's just a function that takes a to-do and returns a boolean in this case. But if we take a look at the detailed type here, then we see that this is not just an expression. Sorry, it's not just a function. It's an expression of a function. What could that mean? That means that C# will, and now listen closely, it will not compile the code to machine language. It will simply not do that. What it will do, it will compile your code into something which is called an expression tree. An expression tree is like the HTML DOM for HTML. You know what the HTML DOM is, right? You take HTML, which is nothing just text, and then you get an object tree where you have your heading and your table and your whatever. You know what the DOM is. And with these expressions, we essentially get exactly the same, but for C#. We get an object tree describing what should be done in this code without compiling it to intermediate language. And what entity framework does behind the scenes, it takes a look at this syntax tree of C# and translates the syntax tree into SQL. Now this was, I'm pretty sure, pretty complicated for a lot of people here in the room. So for now, just trust me. And if you want, I can spend more time next time when we see each other to show you more about the expression trees. But don't worry, you don't need this knowledge to survive the exam and the final exam. This is additional knowledge. This is pushing you a little bit out of your comfort zone. so that we do not just repeat this time. I want to show you more, that there is more. Now, how can we use this expression tree stuff? Let me show you how we can do that. We have to change the method to something that is a little bit different. We will say expression of function of to do converting to do summary, something like this. And then we will say, let's call this one build to do summary, and that is just the lambda function that we had before. So t goes to blah, let's remove that one, let's remove this one, and let's remove this one. So I just restructured the code a tiny little bit. It's no longer a method. You understand what I mean? It's no longer a method. Now it's an expression of a method. And this expression of a method is now an object tree in memory. And now I can do the following. I can simply take this one and return it or pass it to this select statement, and you see the error is gone. Now Entity Framework has a chance to compile this code to SQL because we do not compile it to machine language but to an expression tree. Do you want to see the expression tree? I will show it to you. You do not need to follow along. That's just a demo. So, yep, this one. I'm running this program in my compiler. I hope it will stop here. Come on. Compiler. Hurry up. Faster. Yeah, here we are. Let me show you the expression tree. This is an expression tree. Here you see that we have somewhere a body, see? And in this body, you see that we have a node type, which is a constructor. See that here? Now inside of the constructor, we see that this is, let me see. No, here we see it. We get the arguments. The arguments contain the title, contain the tags with the select statement. We can open that one. That is essentially, what do we have? A function call, you see it? Which method is called? The toArray method is called. Which arguments do we have? This one. Let's take a look at this argument. This argument is another method call, because we call the select method here. Let's take a look at the method. Here it is. Here you see, this is a link method, this is the select method. What arguments do we have? First, the tags. Second, the lambda function. Let's take a look at the lambda function. This is a lambda function. We can take a look at the body. The body contains a member access. Which member? The description member. So you see, the C# compiler didn't generate assembler language. It created an object tree describing the code, just like DOM describes an HTML page. And now that you have this expression tree in memory, somebody, namely Entity Framework, can take a look at this tree and say, okay, how can I translate that to SQL? And somewhere deep inside of Entity Framework, there is a logic that can, for instance, translate a contains method into a like statement in SQL. You get the idea? At least a little bit. Once we have the expression tree, we can also ask C# to give us both. To give us the expression tree and the machine language. That would be then a var build to do summary func. And there we could say build to do summary compile. And that would now take the expression tree and generate the assembler language. And maybe some of you who understood parts of it, might now ask yourself, well, is it possible to build such an expression tree completely at runtime? Is it possible to write an algorithm that generates an expression tree, essentially C# code, at runtime? Yes, it's possible. And nearly all advanced entity framework programs do exactly that. Advanced C# developers all the time generate expression trees. And you can take your C# expression tree and compile it. And this expression tree language contains the entire functionality of C#. So you can do as much metaprogramming as you want. You can generate huge expression trees and at the end call compile, and with that you can do dynamic programming. You can generate C# using C#. You can compile generated C# at runtime into machine language. That's a whole universe of capabilities. Is it necessary to understand what I just told you? No, definitely not for this class. So if the last 15 minutes, I consciously put it at the end, okay? If the last 15 minutes, if I lost you, no problem. Absolutely no problem. Maybe you got a glimpse of what's possible. Maybe you get an idea, and once you leave this school and you start a career at a professional software development company, and the first thing that they wanted to make, the first thing that they do is they want to make fun of you and say, haha, you just finished school, I'm sure you have no idea what an expression tree is. You can say, of course I know what an expression tree is. Or maybe you remember what I just told you and read up the necessary details in the documentation and learn about it. I have detailed videos about it on expression trees also on my YouTube channel. But for this course, you didn't need to fully understand it. But I wanted to show you a little bit, at least a little bit, how this magic of entity framework works in the background. Everything is based on expression trees. That is a huge, unique feature of C#. You can take a look at other programming languages, and they will not have this feature. This is something unique, something special in C#. That distinguishes C# from other languages. Do you have any questions? Well, probably a lot, right? Because it was complicated. Again, it's not absolutely necessary. So, let me show you what we do next. That is all I wanted to show you for today's lesson. See, I gave you the entire sample here in this folder. So you can take the time and go through the entire sample. Make yourself familiar with the code. That is a part of your homework. Read through the code, try to understand it. Yes, it contains the expression tree logic. It contains all the advanced stuff, even the stuff that you don't absolutely need to understand in order to survive this class. The more important thing for your exam and homework and so on is this checklist. I showed you what I have put in this checklist. I also put at the end a list of 10 golden rules. I told you about these golden rules. Follow them. I hope this cheat sheet will serve you well in your exam, your homework, and so on. What I want you for a homework until next time, I want you to work on this homework. I do not give you a sample solution for that. This is something that you have to come up yourself. Let me send you this link. I just sent you this link through Discord. What should you do in this application? In this application, I want you to build an entity framework core with ASP.NET Core application. The goal is to build an API for management investment requests. Yeah? Budgetanforderungen in a school. So if a teacher says, oh, I would like to buy a certain book, which is rather expensive, but we need it for teaching, then this could be an investment request. Our dean could say, hey, I have an investment request. I want to buy 10 new video beamers for classes, for instance. That would be an investment request. And I want you to build an API with which I can add investment requests, update and delete investment requests query functionality, and I want to have a budget statistic functionality. That is the homework. I ask you to implement that from scratch. That's the bare minimum of what you have to be able to solve in order to survive the next exam and your final exam. I think it doesn't even contain a many-to-many relationship. If you want, you can come up with an example for that, but you have seen in today's example, many-to-many is not that complicated. It's really nothing special. It just works. Good? So this is your homework. For those of you who were late, I will stop the recording now.